Hello, everyone. I am Luca Pennella from University of Zurich, University of Trieste, and today I will talk about money in motion, microvelocity, and usage of Ethereum's liquid staking tokens. This is a joint work with the University of Zurich with my colleagues Benjamin Krenar, Nicolo Vallarano, and Claudio Tessone. To word about the motivation, now we start with the basics. Proof of stake. In proof of stake, validators stake native tokens to verify transaction. And from this process, they have rewards that include transaction fees and incentives. But at the same time, we have, if you want a problem or maybe a bless, depends by the point of view, when the tokens are staked, they are often locked that they cannot be used in other type of protocol. For this reason, the liquid staking protocols solves this problem, giving a token that represents the staked token. In this way, people give the staking, but at the same time save another token. This token could be used in, for example, in the DeFi protocols. From this process, we have a question. In which way the people, the users, use this token? Either actively as money in motion or passively, like for savings. But two words about the related work. Microvelocity, it's a tool developed by University of Zurich. And the idea is try to extend the monetary velocity to the address level, to the blockchain. A previous work in this field shows that the wealthier accounts transact disproportionately more, but at the same time, we saw a lot of, centralization in these decentralized networks. Other work about more the ecosystems shows that, for example, in Bitcoin or other blockchain, it's dominated by a few large players. And also, from the governance point of view, we saw that there is a concentration of power. For this reason, okay, what is the situation now in liquid protocols? It's different or it's similar? There are a lot of good works in liquid staking protocols, but more on taxonomics, risk map, and market analysis, but yet little focus on address level dynamics. And the idea is try to bridge this gap by combining velocity metrics and also an analysis about address level. For this reason, our aim is try to measure the velocity of liquid staking tokens to understand the real usage dynamics. And we have four different objectives. One is understand how this token is utilized within Ethereum, also identify which actors drive the velocity, and decompose different usage pattern, and we compare two different tokens inside the Litro protocols, Steve and Rapid Steve, but we will see later what are the difference between these two tokens. What is velocity? Velocity, it's from classically monetary theory, and the idea it's behind the Fisher equation. It links the money supply, its velocity, to nominal economic activity. And the idea is, now in traditional finance, we have the cash. For this reason, we are not able to measure this velocity, but with distributed ledger, we can do that. And the idea is try to apply this idea of velocity inside the blockchain. Very shortly about the velocity. The idea is we have the holding time distribution. It's like a weighted mean about the different tokens held with age data. And we have different holding time distribution for each users. If we accumulate this velocity for each address that we have, for example, in Lido protocols, we have the aggregate velocity of the entire token. And the idea, we apply some computational aspect that it's life of spending policy. What means that the most recent balance are spent first. We also tried the same application with FIFO, that it's the first are spent as first, but the results doesn't change. Maybe it's not super clear. For this reason, I try to do a very beautiful picture, I think. No, I'm joking. We have Alice, And we can see Alice in the first block receive 1.5 hits. After that, at block 5 receive other 10 hits. And the 15 block, Alice send the whole hit to Bob. What we can see that if you see the first part, the 1.5 hit, it's hold for 15 blocks. For this reason, no, the velocity is low. It's 0.1. It's a simple division. It's 1.5 divided by 15. But the other 10 hits, they hold only for 10 blocks. For this reason, the velocity is higher. It's try now to measure the turnover of the token inside each address. We apply this solution on liquid staking in Lido. Why Lido? Because it's the main protocols in Ethereum about liquid staking. To word about Lido, we have two different tokens. The STIF, that is the rebasing token, what means that the balance increase daily for reflect the staking rewards, but it's not RC20 compatible. For this reason, they develop also wrapped STIF. The idea it's a wrapper of the STIF, it's compatible with the RC20 token and you can use in DeFi. It's a fixed balance and the rewards accrue via rising exchange rate. The idea we collection different type of events, but the main three are the transfers and transfer share of STIF and the transfer of rapid STIF. From the first block to the 21 million block, it's like at the half of 2024. Two idea by rapid STIF. No, we say that we start before with the STIF. After that, we take this STIF and wrap it in a rapid STIF. For this reason, we can measure the fraction. And we could see how this fraction increasing during the time. And more or less now it's on the 35% of the total STIF are rapid STIF. Okay, two words about the data collection and processing. We figured some challenge. Why? Because now we say that STIF is a rebasing token. What means that the balance now increase each day. For this reason, we don't have a from to set address. And this is a problem for the velocity. And for this reason, we try to reconstruct the transfer share. This shares, it's only the fraction owned that the people have on the total pool of the Ether that stake. And for do that, we developed two different tools that it's on open source. One is Ethereum Event Tracker. You can use for every event in Ethereum. And the other is the Ethereum Variable Tracker. And the idea is you can retrieve the contract state variables. For example, in our works, these variables are total shares, beacon balance, and buffered Ether. And the idea, no, the processing step is reconstruct the early share denominated transfers because these transfers, it's integrated in Lido only after some blocks. For this reason, we need to reconstruct the previous share with studying the smart contract. But if you want to go deep in the paper, we explain more in detail. To word about the results, this is its average. It's a monthly average velocity of STIF and rapid STIF, and we can see a very high value compared to proof of work and other S320 token. I don't have space for all the velocity of the other token, but we can also see two different phases. A early growth from 2020 to half of 2022. After that, we have a mature regime. It's also interesting to see how rapid STIF its rising velocity, converging with STIF in 2023. This suggests that no rapid STIF is used more inside the DeFi protocols. But also we want to study the holder distribution, how these protocols are centralized or decentralized. On the left, we have the STIF, and we can see how only 1,000 hundreds, more or less, it's 0.25%, hold more than 140 million. It's very big, no? It's quite skewed distribution. In rapid stiff, it's also worse if you want from decentralized point of view, because only 78 address hold like at least 150 million. Also about the small holders, we can see how the small holders share much lower in rapid stiff than stiff. This suggests, in our opinion, that the rapid stiff is used by the biggest institutional player, but by the biggest player, not for the retailer users. Also, we can see, maybe it's not super clear, but it's a log scale. And the idea is how to show that the microvelocity it's driven by the whales. For this reason, all the turnover inside this protocol, at least the major part, it's driven by the whales. We have two different user typologies. We have the high capacity accounts that we said before, it's a few addresses that transact very large volumes. And also, we see later, integrated into the file infrastructure. A smaller account, it's a lot of address, but with low activity. This suggests that it's more passive instrument. It's more for edge the inflection, more for now collecting the reward. Another figure that could be interesting is see how the top DeFi holders of rapid stiff, it's not sex holders. It's like Aave, Spark, Skymoner, Balancer. It's all protocol that use rapid stiff in some strategy of lending or in some pool. And for this reason, also from the figure, we can see how the the total hold of the balance is controlled by only few players. In summary, we see that now we have high turnover, a very high velocity, but it's driven only by the biggest users. Also, we have a concentration. The whale dominates the holders, the balance, but also the velocity. And the very interesting part, in my opinion, is see how to the major protocols use Lido protocols for some strategy. Yes, what is the idea of our contribution? We try to apply this novel framework, try to understand better how to work the velocity on these liquid staking tokens. It's for our knowledge, the first address level study of liquid token circulation. We find a lot of asymmetries a lot of concentration, a lot of asymmetries in these type of tokens. All data and tools, also the script, it's on GitHub, it's open source. But I think the most interesting part, it's the futures work, because it's like a start work. And we want to apply this micro velocity, for example, on the stable coin, because now could be interesting to see how this stable coin could be used, but also try to use, to link to the keynote of tomorrow. The idea is try to go vertical about the micro velocity, but not only micro velocity, more the analysis of the DeFi ecosystem, and try to understand if we find recursive leverage in Ethereum. Now, if people take this rapid stiff, for example, and try to put this token for leverage strategy for this composability risk. Yes, this is our work. You can find the paper on archive. I am happy to discuss, to answer the question. It's a working paper. We try to improve it, to understand better also the microvelocity part, because it's a new application. We think there is some room for improvement. Yes, thank you for your attention.
Thank you very much for your talk. So, as I understand, your results are very based on the IDs of the users, right? On the uh, uh, do you account for the possibility of two IDs pertaining to the same user? Mhm.
Yes, good question. We don't study this level. We take all the addresses. For this reason, our granular it's one addresses. We are not interested to study the, how to say, the ID. We did do only for the, no, for the top holders. For example, you can see, no, two addresses are from Sky only. No, for this reason, for the biggest, no, institution, we are able to have a label data set. For this reason, we are able to do that. For the smallest one, no. Thank you.